Alright guys, let's read your description, okay? Points R and S lie on the circumference of a circle of centre O and radius 8.5, alright? So you're going to draw yourself, you're going to put down your centre of your circle and you're going to draw yourself a circle, okay? That's a good start, a good solid start, shall we say. Now, there's your circle, happy days. R and S could be absolutely anywhere, would you agree with that? R and S could be anywhere. Now, which is the... Now, R and S lie on circumference of a circle O. The point T lies on the major arc RS. What does it mean by major arc? So, for argument's sake, I say that's R and that's S. Which one's the minor arc and which one's the major arc? Yellow is major arc, and what would blue be? Is everybody now happy with the definition of major versus minor arc? Happy days. You can lower down one or two of those blinds to make it a bit darker if you want. Okay. Now, yeah. Christian's one. Yeah, that's perfect, Christian. Thank you. Okay. Now, next thing after that is T lies on the major arc. So CT, I can put that anywhere I want. Okay, I can go anywhere I want with this. So look, I'll just put it up the top, dead center. Just makes the diagram a bit more easy to interpret. We good with that? Okay. Now, it says RTS is what? 0.4 of a radian. Okay, 0.4 of a radian. Calculate the minor arc RS. No bother. Now there's a rule. Does anybody remember this rule from junior cert? I call this the Star Trek sign because I'm a big nerd. Alright? So the old school Star Trek sign looks something like that, okay? And so if that one is 0.4, then the one that's based at the centre of the circle must be what? 0.8. That's it. Alright? Now, only when T is on the circle. So, example is if I move T off the circle like this. If I said T, if T wasn't on the circle and T was off the circle, that rule no longer applies. All three of them have to be on the circle, okay? And they have to be standing on the same arc. So, do you see the way? This angle, its legs start at R and S. Do you see that? And it ends in the centre of the circle. And see the way the angle for T also stands on R and S. They're actually standing on the minor arc RS. That's why one of them is half the other one. Daily. No, what I said was, it doesn't matter. So, example would be this daily. Good question. I did cover that earlier, but we'll do it one more time. Okay. I said that T can be placed anywhere. Alright. And if I place T over here for argument's sake, like that, that will still be 0.4 because we're told it's 0.4, and that will still be 0.8 no matter what its placement is. So sometimes you have a Star Trek sign, sometimes you have something that looks nothing like it. So for example is if I move T a bit further, what happens if I move T a bit further, it looks like something completely different. So if I move T all the way over here, it's worth doing this just to show you what it could look like. It starts to look absolutely horrendous, to be honest. It's still the same question. Alright? You might not think it, but it's still the same question. That's still 0.4, even though it looks completely different, that's still 0.4, and that one is still 0.8, no matter what way I draw it. Is that okay with you guys? That is great that you asked that, because now that question looks completely different than how it started, but you all know it's the same thing, right? Now, I'm after the length of the minor arc, so what is this then? Anybody care to know how to do this? If it's in radians, what can I do? L equals R theta, yeah? And then what is R again? Yeah, so what's 8.5 times 0.8? 6.8? What? 6.8, thank you. Oh, it's there already. Sorry, yeah, I didn't even notice it there. Grant. You might see that the solutions diagram is a bit different than mine, but that's a-okay, right? A-okay. You can do. Got me an A1 at the end of the day, so I can't complain. Right, so a circle of circumference 12 centimeters is described in a square, which in turn is inscribed in an outer circle. This outer circle touches the parallel sides of a trapezium as shown. Happy days. Find the areas of trapezium, given your answers in the form a root b over pi. Now, the only thing we need to find is this. That's the only thing we need, is that red line. Everybody cool with that? Why is that the only thing we need? Because the area of a trapezium is, what's it, a plus b, a different over 2 multiplied by h. And we already know the a and the b value, don't we? What are the a and b value?
5 and 2.
We already got 5 and 2. Okay? So it's, what's it, 3.5 times h? H is the red line, yeah? Now we got to focus all our energy on trying to find this red line. Now, it gives us the circumference of the small circle. Does everybody see it? That's handy information to have. That yellow line. So what is the yellow line again? Anybody tell me? It's the circumference, which is 2 pi r. Okay, so we get 2 pi r equals 12. And then r must be, we'll keep it in terms of pi. 12 divided by 2 pi, otherwise known as 6 over pi. Is that cool with you guys? Alrighty. Now, if I draw the square, so actually we now have the height of the square, don't we? We also have the height of the square, which is handy. Ah, yeah, we got it. Alright. So, look at this. Can anybody tell me what is the length of the square then? The length of the square is 2 radiuses worth, isn't it? Would everybody agree with that? So the length of the square is 2 radius worths, which is 12 over pi. Is that okay? So it's 12 over pi across and 12 over pi down. Now the next thing I'm after is, I would love to know the diameter of the circle. That red line I'm after is the diameter of the circle, isn't it? Now, where is the diameter of the circle? I'd argue that the diameter of the circle is the distance between those 2 red points. And where do I put those 2 red points? Here and here. Here's the diameter of my circle, or that red line I was looking for earlier. Just do Pythagoras' theorem and we're in business. Call it distance d. Actually, or it's actually known as h, isn't it? Because it's the same distance. So we'll call it h. And then h squared equals 12 over pi squared plus 12 over pi squared. Alright, take out the calculator for that. But everybody agree it's 144 over pi squared. Alright, and then add that to itself. Square root it. Does it want the answer in terms of pi? Oh, it does, so scratch that. It's 144 over pi squared. That'll make that 288 over pi squared. Square root 288. Root 288 is 12 root 2. So h is 12 root 2 over pi. Everybody cool with that? 12 root 2 over pi. Now, what did we say earlier? The area is, anybody? 3.5 h. 3.5 multiplied by 12 root 2 over pi. Ignore the 12 root, ignore the root 2 and the pi part. Just don't pay attention to it. Just do 12 times 3.5. What's 12 times 3.5? Yeah, that's the one. Is that what you got, Mick? Good man. 40 root 2. 42 root 2. Good man. Okay, guys. Derive a formula in terms of r and theta radians for the area of a minor segment under the chord BC. For the area of minor segment chord BC. Hence find the ratio of the area of the major segment to the area of the minor segment, subtended by the angle of pi over 2 radians. Ouch. So when I read this, here's what I'm thinking. All right. So first of all, if you take away the full thing, and you just draw it without it, your minor segment is actually just that, and your major segment is the top part. So that's your minor segment. That's your major segment. Is that the way the question's constructed? Okay. Next thing, derive its form in terms of r and theta for the, it's no bother. That's professional. Alright, you can get the area of the yellow part, can't you? And you can also get the area of the blue part. So area of the yellow part and area of the blue part in terms of theta and radians, right? Okay. Now, so area of the minor segments under chords. So it only wants the minor segment, doesn't it? Yeah. So I'm going to do the negative with that. We're actually going to go for, I'm just thinking, I'm not going to do 360 take away theta because that's just going to be awkward. There's an easier way. Here's my easier way. My easier way is to do the full pizza slice. Full pizza slice, take away the yellow triangle. That the route you should take? Perfect. Yellow pizza slice, take away yellow triangle. Sorry, green pizza slice, take away yellow triangle. Everybody got that? Let's start with the green pizza slice. What is it? Area of a segment is a half r squared theta. And that's it. That's the green part. Okay? And then what we're looking for next? The area of the triangle, a half AB sine CD is, okay, and then we just do minus a half. A and B are r, which makes a half r squared, and then that's just sine theta, and there's your formula. There she blows. Alright, wasn't too bad. Now, hence find the ratio of the area of the major segment to the area of the minor segment. So basically replace theta with pi over 2, yeah? Theta is 90 degrees. So here's what we're going to do. A half r squared theta. Oh sorry, we already know theta, don't we? It's pi over 2 minus a half r squared, what's a sine pi over 2? What is sine pi over 2? Sine, it's 1, isn't it?
Yeah.
So it's minus a half r squared, and what's that then? That's everybody get that for the minor segment? Anybody get this as well? Alright, next thing. Lads, I could do the major segment, but does anybody have a shortcut for me? Why don't I just do the... so the whole point is I need to find the ratio of the major segment to the area of the minor segment. It's major segment divided by minor segment. And what I'm thinking is, I'm just going to get the area of the full triangle and take away the minor segments. Do you get what I'm saying? Area of the full circle, take away the minor segments. Oh, wait a second. Yeah, I have it. It's all good. So the major segment is this part here. The minor segment is this red part here. And the red part is given to us by this formula here. So the major segments is pi r squared, take away, pi r squared over 4 minus a half r squared. Did anybody get 3/4 pi r squared?
Yeah.
And then plus a half r squared?
Yeah.
Okay. Next thing we're going to do is we're going to divide the major by the minor, okay? So I'm going to factorize out r squared, just for argument's sake. And it's not a nice finish to the question, as in, it looks really, oh wait, what else did I do there? Half, yeah. And here, minus a half. Alright, for me the ratio is 3 over 4 pi plus a half, and then on the bottom is what? Pi over 4 minus a half. That's the ratio. So what did you say? What? Yeah, you could. Yeah, I was just about to get. You can multiply both sides. So when you put them as a ratio. No, he's definitely right. Like, it's just one presentation over another, right? And I'd be inclined to agree with Jamie. I don't tend to like fractions as much as the next person. So imagine you had the ratio 5:2. Lads, listen. Imagine you had the ratio 5:2. You can multiply by any number you want. So I could express that as 10:4. Do you get what I'm saying? If I have a ratio of, for argument's sake, a half is to a quarter. See, a half is to a quarter. If I multiply both sides by 4, what will happen? 2 is to 1. So I'd be inclined to multiply both sides by 4 here. And I'd get a 3 pi plus 2 is to, what's it, pi minus 2? That's the ratio I'd use. Is that the ratio that's in the solutions, is it? There you go. Nice and calm. Alright. Now, let's move on. What's that? 9 followed by 11, was it? 5, 9, 11. Alright, let's go with 13, guys. If the area of a sector of a circle is 48 centimeters squared and the perimeter is 28, find the length of the radius. Okay, no bother. This one seems relatively easy. Sorry for keep saying that, it must be annoying. Now, we give it a random angle. I don't like drawing theta, so I'm just going to call it a B. I don't like theta. Now, we call the two of them the radiuses, yeah? And we call this length here the arc length L, yeah? Yeah. Now, I'm going to get it in terms of, I'm going to use radians, okay? So I'm not using degrees, I'm going to use radians, okay? Now, here's what I've learned so far. What's L plus 2R? Anybody? L plus 2R? 48. Okay? Oh, 28, thank you. It's the perimeter, not the area, lads. Big mix solutions, same thing. Alright? Now, alright guys, a half r squared theta. What's a half r squared theta? That's the area formula using radians, and that equals 48. Now, the deal is, it's length of the radius. Okay, so you can see where we might get a bit. One formula I haven't used yet, isn't there? What's L equal to? Yeah. How did I know I needed a third formula, lads? How did I know I was in trouble? 3 variables, 2 equations. Does everybody understand that? I had 3 letters and 2 equations. I knew I was in trouble. Okay? So then I realised, oh, L equals R theta. No bother. If I get rid of that L and throw in R theta, how many variables do I have now? 2 variables, 2 equations. That means the question is answerable. Okay? Now here's my plan. It wants the radius, so I'm going to try and get the I'm going to get rid of theta. So here's what I'll do. You can do it a number of ways, but I think I'm going to do it this way. 2 times 48. 96 over r squared is nice, isn't it? Then sub it into this equation here, and we get r times 96 over r squared plus 2r equals 28. Then what happens then? Smash, smash. Common denominator of r, isn't it? Or multiply across by r. Smash. Tell you what, somebody just give you the 2 answers for this. You can either minus b it or you can factorize it. Your call. I'm pretty easy with it. What are the r values? 6 and 8. Is everybody happy with just solving the quadratic yourself? Alright. 1 left. Or 2 left. That's 13. 1 left, lads. Alright. Alright. If I get this done quickly, I'll get to see the memes. Now, a farmer has a shed measuring 4 metres by 5 metres in this. Dad, can I do my work, please? Thank you. A farmer has a shed measuring 4 metres by 5 metres in the centre of a large field of grass. Okay, he ties a goat to one corner of this shed and uses a rope measuring 8 metres, allows him to graze on the grass. Okay, so here's what I'm thinking. This is 4 by 5, probably. Yeah, that's more like it. That's 5, that's 4. We'll put the goat down here, and the goat has a rope measuring 8. So if you imagine a circle of 8, so the circle is actually longer than the shed. That's 5 metres, then another 3. So the goat is technically, this is technically the diagram, isn't it? Now, I don't know if the goat, okay, so using rope measure allows the graze of grass. Draw a diagram showing the grazing area of the goats. Indicate in the diagram the different sectors of circles represent this area. Alright, what I'm thinking is the goat is, this is an unusual question. The goat is, let's go over a second. The goat can, the rope can bend and follow the goat. So for example is, alright, if this is the rope, that's 4 metres. Then the goat can go another 4 metres in this direction, can't it? So technically it's a quarter of a circle. So I'm going to have to typex all this out in a second. That's part of your answer. I haven't looked at the solutions at all, so I'm coming up with this from scratch, okay? Now, I'm going to get rid of the writing down the bottom. So my diagram is, okay. Alright, next thing. So, it's safe to say that that has an extra 4 metres it can travel there. So, sorry guys, just 1 sec. I just want to. Okay, now it's safe to say that the goat can go all the way up here as well, can't it? How many metres is that away? Oh, 8 metres. It can only go another 4 metres this way. Is that right? So the goat has a bigger circle of 8. Sorry, you have to excuse me for a second. I'm just trying to. 8. Sorry. Let's just be quiet for a sec. When you're seeing a question for the first time, there's a lot of noise. I can't focus on what I meant to do. Okay? Do you guys remember seeing this question for the first time last night? It's quite difficult, right? So you have to get into your head what exactly you're doing, okay? Now, what I'm getting into my head here is that this is the 4x5 shed in a plot of nowhere. The goat can travel 8 meters using the rope. So if it's attached here, the goat could be all the way up here. Does that make sense? Alright? Now, the goat, however, the rope gets stuck here. See this green spot here? The goat gets stuck there, and when the goat goes around the corner, he's only allowed to use this area here. Does that make sense as well? Because it's sort of anchoring on that green point. Is that what the solutions have? Yeah, exactly, right? You can think through this stuff, right? Next thing. 4 meters up, it can go all the way around here, happy days. It can go all the way to here. The goat can, oh wait, that would be, what's that? That's 5 meters. And then an extra 3, isn't it? So, that's 8. Yeah, that's perfect. So this is a distance of 3 meters from its 5, but that's still 8 meters away. So if the goat was here, would everybody agree that's still 8 meters away from the rope? Okay, now we got to do another arc here, don't we? It can only be tethered at 3 meters per 3 meters, right? So we draw another circle. Once again, I have to come back with my my Tipp-Ex just to make this a bit better. Okay, thickness a bit further. So we're gonna get rid of that. Get rid of that. Get rid of that. There's no need for that. And there we go. We have our answer. Alright? Would everybody agree that it's 3/4 of the big circle? Everybody agree it's 3/4 of the big circle? Does everybody see that? So that's 3/4 of a circle of size 8. Alright? Radius is 8. Get the area of that circle. Then you have a quarter of a circle of radius radius 4. A quarter of a circle of radius 4. Okay? That's your other area. And then finally you have a quarter of a radius 3 as well. And you just get those areas and add them together, and that will give you the area of the goat. Is that the correct solution? Perfect. Alright, really quickly.